Hello, everyone, and thank you for joining today's webinar, How to Use Microservices to Build a Data Lake on AWS. My name is Brett Carpenter. I'm the marketing strategist here at Zaloni, and I'll be your MC for this webcast. Our speaker today will be Sabyasachi Gupta, a software architect here at Zaloni. We'll have time to answer your questions at the end of the presentation, so don't hesitate to ask them at any point using the Ask a Question tab below the player. We'll also be having an interactive poll during the webinar, which can be accessed using the Vote tab below the player window. Before we begin, I'd like to introduce you to Zaloni. Put simply, Zaloni simplifies big data. We help customers modernize their data architecture and operationalize their data lakes to incorporate data into everyday business practices. We supply the Zaloni Data Platform, which provides comprehensive data management, governance, and self-service capabilities. We also provide professional services and solutions that help you get your big data projects up and running fast. Now with that, I'll turn it over to Sabby to discuss how microservices play a role in building a data lake on AWS. Sabby?
Thanks, Brett. Hello, everyone. This is Sabby Gupta, and today what we're going to talk about is how we can leverage microservices to build a data lake on AWS. I know there are a lot of other cloud providers, but we'll focus our talk on AWS today. So what we are going to cover today? The agenda is as follows. Definitely it's a microservices talk, so we'll try to understand what microservices are, what the principles, go through a reference architecture. Microservices can be a big topic on itself to discuss, so we will try to just go over the principles at a high level and see how that can be leveraged on accomplishing data lake on AWS. Then we will talk about the logical components of the data lake. So at the end of this presentation, you should be able to understand, to build a data lake, what are the logical components you need so that you can build on your own if you want to. Eventually, we want to build our application, our data lake application, on a microservices architecture, and that too on AWS. So I'll go through a couple of approaches where I will showcase what if you use AWS infrastructure but don't use all of the components of AWS. What if you want to use your own stack to build on AWS, like you want to just leverage the compute power and the storages of AWS, but you want to have your own tech stack to build it. So that will be kind of a generalized design, which I'll showcase. And then I'll go into a bit more specialized design where I can leverage other components of AWS to build the data lake solution. Eventually, we'll tie all the things up. We'll go through a reference system architecture as to how it would look when things get working on the platform. Eventually, at the end, we'll cover some questions and answers, and I'll answer some of the questions from you. So, what are microservices? Before I get deeper into what microservices are and what it means, let's do a quick poll. Brett?
Okay, so the question is, what is a microservice architecture to you? A, it uses containers. B, it uses cloud. C, it uses API-first design. D, it uses domain-driven design. Or E, it's all of the above. And you can vote on this using the Vote tab in your player window.
So votes are coming in. There's an even split between users, containers, and all the above. Some people are saying uses API first design. I think we'll keep it open for a couple of more seconds. All the above is picking up. Okay, cool. I think we'll stop and we'll see how much. What is it? Okay, so what does it look like? I think majority says all the above. There's a close second. It says uses API first design. Actually, the answer is all the above. So microservices architecture is actually encompassing all of these different principles of development and design. So microservice architecture will use containers. It can be used in the cloud, obviously. As you can see, that they talk about. API first is definitely one of the biggest tenets of using microservices design. So that would make sense. And domain-driven design is also one of the big components. And you will see, like in the principles, like what does that mean? So thanks for your responses. Now let's get deeper. So here's a definition of what microservices architecture really is. The fun part is, like, if you bring in 5 people into a room and ask what microservices architecture is, you will get 7 different answers. So it is that everybody has an opinion as to what microservices architecture is all about. The one I chose was from Martin Flower. He was a pioneer of like proposing and evangelizing about microservices architecture. So what he talks about in this paragraph is pretty apt, and it covers actually what if you have to practice microservices architecture, what does it mean? So microservices architecture is definitely a suite of small services. That's what micro talks about. There's always a comparison to monolith applications, and so microservices is kind of the opposite of it. So these are small services which are contained by itself. They are running on their own processes because if you have multiple components running in the same process, you're getting dependencies in terms of they're impacting each other in terms of compute. And if you have to change one, then you're impacting the other because you have to bring down the container, for example, or the node, for example, if you're using just nodes and not containers. So it's better. It's prescribed to make it run in their own processes, and because they're running in their processes, they're distributed, so they need to communicate with lightweight mechanisms, often an HTTP endpoint, because HTTP is ubiquitous, and leveraging that makes things very simple. If you have to do some remote procedure calls between processes. Definitely, one of the key things is it has to be built on business capabilities, because we are building a service is kind of solving a business problem. So it needs to be built across business capabilities. This is one area where it becomes a bit of an art than science, where you need to know, like, what constitutes a business capability that can be put in a microservice. Does it cater to a couple of business capabilities, or it needs to be just one? And there is no right and wrong answer. And once we get to the principles, you will see, like, what are some of the thumb rules we can apply to see the granularity of the microservice component is correct. Then once you have built, you deploy it. So we need to make sure they're independent and deployable. Microservices are, as I alluded to before, on the point of monolith applications and architectures. It is like, if we were in a monolith application, then we were deploying the whole unit together, which sometimes creates problem because my application is most probably made up of smaller units, and if I change even a tiny part of it, I have to deploy the whole thing, which increases risk for us. So microservice architecture helps us with that. Automated deployment, because you want to automate things, you want to take out the manual part, involvement of the whole process to make it more agile. And last but not the least is like leveraging different programming languages and different storage technologies, because microservice architecture, it is the surface area is small, so people can use their own languages and use different storage technologies to build each of the microservices. Now, it's not like one size fits all. It's like depending on the use case and what the team strengths are, what the team wants to do. they can choose their own destiny, kind of. So now that we understand what microservice definition is, so let's skim through a bit. As I said, this can be a discussion by itself, but I'll just try to gloss over as to what it means. What are some of the principles you need to follow to make microservices in your design. Before I get to the points, I would recommend reading this book, which is called Building Microservices by Sam Newman. He has been preaching microservices for a long time. It's a pretty good book. So feel free to take a read at a later point. So some of the principles are obviously building on top of a business domain and modeling it. So what that means is, like, for example, let's take Amazon as an example. Like if you are building an e-commerce application, then you have customer. So customer can be part of like billing, where you need a billing address, and part of delivery, where you need a delivery address. In the past, you might have one customer object, kind of a big object which has everything in it. But with microservices, it is like it's okay to have multiple types of customers. In terms of properties, they don't overlap, but it's okay to have that. The reason being, in monolith era or paradigm, that becomes a God class, like it's a big class. So if you change one, you're impacting another part of the application or another part of the service. So it couples the teams if there are two different teams, most probably. So that's why use your judgment to build that. A good way of doing and seeing like how I can do that is through understanding domain-driven design. There are quite a few books around it. So domain-driven design would help you. And at the end of the day, as I said, like this is an area which is a bit of an art than science. But yeah, following that would help you. Automation is definitely important because you want to automate things in terms of automation. When I say automation, it's not just about development. It's about automating your testing through things like SOAP UI and all that stuff. Some way of automating your pipeline. Your build pipeline you can automate. If you're in AWS, you have things like tools to automate that. If you're doing on your own, you have Jenkins, for example, to automate your pipeline, development pipeline. You want to encapsulate and aggregate your microservices. What that means is, comparing it to monolith architecture, you would most probably have like one database, and even if you have multiple services, they're talking to a single database to get data and do CRUD operations on top of it. That the problem with that is like if you change the schema, because now the schema becomes coupled with different services. So if you change the schema, it impacts others. As you can see, the mantra of this is like loose coupling, so that the dependencies are kind of broken. So even if you change one part of it, it doesn't impact the other. Because and you will see like why it doesn't impact the other, because you're following something like an API first design. So encapsulate your microservices to reduce your service area of change. You want self-service and autonomy. As a team, I want to make choices as to what I need to do with my service, what tools, technologies I can use. So it gives you autonomy. It's not like, as I said, it's not one size fits all, which is good. You want to deploy independently. You want to control your own destiny. So if a big application is built of multiple microservices and I control one part of it, so if I change it, I should be able to deploy it on my own. So microservices give you that functionality. API first design, definitely you want to have APIs. API should be the entry point for other services and external clients. If you're exposing an API to public, say on a public domain or something like that, so API should be that, and you have to read through like what are the best practices of doing it, like versioning it and making your APIs backward compatible wherever possible. So following that best practices would help you build a good microservice application. Failure isolation. Your applications need to be fault tolerant. There are various approaches. Some of the basic techniques used is like kind of circuit breakers. If one part of the node is not working, because you're like running your application on multiple nodes. You might have there's a concept called bulkheading, where like it's the concept is taken from ships. Like ships are different compartments, so that even if there's a hole in one part of it, it can be contained and the ship doesn't sink. So there are different applications and tools which help you take the same paradigm and implement it. And DevOps at the end of the day, because as you can see, the mantra is like building your own, like controlling your own destiny. So if you build it, you own it, and you deploy it. So the whole experience you need to control, and that comes through the DevOps paradigm. So that should give you a flavor as to what a microservices principles are and the tenets you need to follow to build a good microservice application. So you must be wondering so far, like, okay, I understand the principles. Where do I start? Because at the end of the day, I need to write some code, lines of code, to realize all of this. This is one of the frameworks which I found pretty useful. It's called JHipster. So feel free to take a look at it. What it does is it's an opinionated way of microservices, of executing and applying microservices architecture. It is built on complete open source, like Netflix open source, and Spring Cloud, and optionally Docker. I mean, it has Docker. Docker containers is their first citizen, but you don't have to use containers like Docker, for example. But it is, so JHipster helps you get kickstarted, get onboarded into microservice architecture very quickly, like within minutes. Once you install its framework, within minutes you will be up and running. So the major components are, it uses kind of a gateway design pattern. So at the top of it, as you can see, the browser is using the gateway. Gateway has your UI code, and it is interacting as kind of a reverse proxy to your microservices. You can have like n number of microservices, and Gateway actually dynamically, with the help of the JHipster registry, which is kind of Spring Cloud, it has a Eureka server and a config server, which helps us discover what all microservices are up and running, because you can have a cluster of microservices. So using that, the components can discover where I need to talk to. So as you can see, that makes it completely decoupled. You can scale elastically. So the framework gives you that ease of use. Gateway, what it also does, it also acts as load balancer, and because there are multiple microservices running, so it will try to pick up which one is available. So that is the role of the gateway. The microservices are the ones which is kind of having the business logic implementing for the application. And eventually there is an option to also do things like, there's something called JHipster console, which actually kind of captures the logs and all that stuff. It's an optional component. If you have your own logging mechanism, you can use that. It basically uses the Elk stack, Elasticsearch, Logstash, and Kibana to do its job. So this is kind of putting some like whatever I just said about the principles. This is kind of realizing those principles. So using this framework, I'm pretty sure there are others, but this is one which is pretty common and very useful. So using this technology stack, we can get onboarded onto the microservices paradigm very quickly. Now that we know about microservices, what their principles are, and how I can start building an application on microservices, let's get into the data lake part of it. To see like what data lake means. If I have to build a data lake application, which is kind of a buzzword, and everybody is trying to do it because of the data proliferation across, whether it's from IoTs or other places, we need to kind of like have a data lake to do all that. Do all that stuff. When I say do all that stuff, means like you need to enable like files and data coming into your system, and then you want to have governance, because otherwise it will be kind of a wild west. But you need governance around what people can do, what people can see, privacy and all that stuff. You know, nowadays data privacy is key. So how do you govern, and how do you engage? So now you have the data, you have governance around it. Now how do you engage people to use it? So covering these three major big pillars would make you are like a good data lake application. So what does each of these mean, right? So when you say enable, so I can start building some, how do I start making some microservices around it? So going back to like business capabilities, I think that one of the principles you need to apply over here. So like, try to see what are the business capabilities I'm trying to get out of it. So some might be, say the top two is kind of using, there's some ingestions like batch and streaming, so that can be a candidate for a good one microservice. I need to capture metadata from somewhere, whether a file is coming in or I'm discovering, doing an auto discovery of the metadata. So these two are kind of say two different microservices. They can be one, but let's say start with two of them. Then once I capture all of that, then I might have to do some data quality, making sure the data which is coming in makes sense. I might do some joins here and there to enrich the data, maintain the life cycle of the data as to how long it lives on the servers, on the storages, and all that stuff. Obviously, you need to apply security around it, so authentication mechanisms. You need to catalog so that people can get into your application and see what are the different entities and all that stuff available, so that people can operate on it, or people can pull some data out of that system into somewhere else, like spreadsheets or CSV files or something like that, and eventually make it self-serve. As I said, like if people want to explore the catalog and try to do some things on top of it, like exporting some data for, say, you want to run like a machine learning model on a snapshot of data, so that you should be able to get into the catalog, figure it out what data sets you need, and push that snapshot of a data set from there into your machine learning model. So that is kind of a self-serve. So all of these can be good candidates of microservices. So peeling the onion, getting a bit deeper, what it means is when we would need some sources, because we need data coming into a data lake. So the sources can be databases, it can be files, batch files, streams, Kafka streams, for example. It can also even be an API, like say Salesforce API. I'm trying to get, say, campaign data out of it, for example. So I can call the API and get whatever I need. So we need sources, so data coming in. Then once the data is there, we need to ingest it out. So different ways of ingestion. If it is streams, using something like Kinesis or Kafka, for example. If it is batch files, some other storage layer using like S3 or Glacier or some other file storage mechanisms. So that goes. So once the data is ingested, you need to store it somewhere. That is a storage layer. You need a storage layer for that. Then once the data is stored, most probably people want to process on top of it. Like people want to transform it, do some joins, make some data inference, do some predictive model, and you need like execution engines. You need processing for that. So you can use Spark, for example, Hive if you're in MapReduce, leverage EMR or Lambda, for example, and you'll see how they fit in each of the microservices in future in the slides coming. Then obviously all of these need to be exposed to a web layer for people to get into. If there's a browser-based experience, then obviously like a Tomcat, for example, use Spring Boot, gets you started pretty quickly. Very opinionated way of doing things, which is good. You can use, if you're using a pure API, you might use like an Amazon API gateway to get stuff. And if you're doing API development, one of the good tools is like using Swagger, because it gives you a design, like top-down approach to it. So it's more of an API first design paradigm. It helps you. There are other tools, but Swagger is kind of the market leader. So you should take a look at it if you haven't. Then last but not the least is kind of the consumption layer, like who are the applications we're trying to consume If it is kind of a data science application, might be it's a Python script or a R script. If you're just trying to visualize Tableau or Kibana, you're running some machine learning algorithms, might be some other application you want to use, like a notebook or something like that. And eventually, you want some governance and data management. For that, you can use like Glue, for example. Usually, like Glue is kind of making sure whatever data is coming in, because everything might not go through your data lake application, but still your data lake should be able to discover what is getting into the data lake. So Glue helps you do that. It helps you catalog to various mechanisms, and to monitor and making sure that what is happening, people who are accessing the system and all the stuff, they're doing it in the right shape and form. You can use things like AWS CloudTrail to mine the logs and make sure the access patterns make sense. People are not trying to misuse the data and all that stuff. So that covers the data management and the governance part of building a data lake. So let's next couple of slides, what we'll say is like if you have to build this whole design of a data lake in cloud, what does it mean? So I'll give you the first design is we are building the application in cloud, but we will be using JHipster, for example, or any other tech stack, whatever you want to use to build it, without using any S3 like AWS components. So I'm building this application on obviously AWS. So say I have an EC2 instance or multiple EC2 instances. To build the data lake, what I need a gateway service to be built, because that is the entry point. So you need a kind of an API so that people can call into an API or get into an UI. So you will have the JHipster framework there, and it will be built on Angular. So you will have your UIs will be built on Angular, and your APIs say will be consumed like a REST API, for example. So you need the gateway, you need kind of the ingestion service, because the data is coming in, like say if there are files or streams, so your ingestion microservice, which is running on its own in some server, it is able to ingest data which is coming in from outside. So there might be different agents to push data into your cloud infrastructure. In this case, your ingestion microservice. So as you can see, this microservice is not mostly dependent on the others. This is like a decoupled microservice from the other microservices. It's running in your cloud space, and it is looking for files and streams, and it will get those files and streams, whatever the way you implement it, most probably say through Kafka or say any store. Like if you're in AWS, use S3 as your store. If you're in Azure, use Azure Blob Storage as your storage there. So that microservice is just looking for data coming in so that it can push it into the data lake. And once it does it, it would also try to put some inventory around it, some trails, some messages into Elasticsearch saying that, okay, I cataloged or I got this data file, and this is all about, these are the details of it, so that you can later go through that Elasticsearch log and see what came into the data lake. So kind of an audit trail, you have it. Then you will have an inventory service. One of the scenarios is like, so the ingestion is kind of the data coming in from outside, so you know what is getting in. Inventory is, what if somebody created some entities and objects in the data lake outside of this application? How do you make sure your data lake is aware of it? So you will, that's what I'm calling inventory. So it's kind of making sure whatever is there, whatever's data inventory is out there in your data lake, I am making sure I have a handle of it. So your inventory microservice is responsible for that. For that, you can use things like Spark. Spark is pretty good at doing it. The reason, the challenge over here is like the data sets sometimes can be unstructured. It can just be files. How do you know what is the structure of that file? If it's CSV, it is easy because I know it's CSV, for example. I know how to parse the structure. But still, the challenge from CSV, for example, comes. I might know that these are the different fields, but I don't know what the types of the fields are. and all that stuff. So there is a challenge if it is an unstructured, like if it is files, not databases, which I'm trying to inventory, because databases give you a lot of metadata, but files out of the box don't. To get all of that, like CSV was one. Say, for example, you have a JSON file. How do you get a structure of it? So you will use, so Spark does that pretty well. So it has good features like that. So you will most probably implement that in your inventory microservice, so that you can inventory your data sets. Then catalog is, so once I inventory it, I want users to use my catalog and discover and like collaborate on it. Might be do some ratings on that, so that the popular ones trickle up, and people can start discovering, okay, which data sets make sense. If I'm doing a data science modeling, then which data sets I need to look, because there might be different variants of the same data set. So catalog makes it collaborative from a data catalog point of view. Then obviously security microservice, you need to ensure the access to the systems are right. Whoever is getting in, whatever the authorization levels are, that is maintained. So you can use LDAP for that, for example. There's so much of, now you can see there's so much of data getting into the system. So whether it's like operational data, metadata, or just pure data, you want to search through it. So you want a dedicated search service, which is just aggregating across all of this. Might be there's a crawler which is scrolling across all of these things and like indexing it into, say, for example, Elasticsearch. When you have data, you want to run transformations, complex transformations, like big data transformations. So you would need a microservice for that, so that people can submit their jobs, for example. And a good way of executing a big data job is through Spark. You can use others to Hive. If you're interested in MapReduce, you can do that. You can use other technologies, but the key to know is like you need some way of like making sure you have a microservice which takes a request, takes a job detail, and then cranks through it, working with the cluster. And then the usual ones, you need an admin microservice, so that its sole job is to make sure new users get onboarded. There is some user management around it, and other responsibilities, whatever admin microservice does. And last but not least, the logging, which is pretty important, because you want to log things into your application for troubleshooting and making sure if something goes wrong. Nowadays, there are a lot of advanced tools like Splunk and all, so they can make a lot of sense from logs. So you want a microservice kind of a dedicated to capturing logs from across all of these. These can be kind of this logging microservice can capture logs real time, like through streams. If you're using Logstash, then you might be streaming your log data, or it can also be aggregating logs from files. So it depends how you implement it. So I hope this gives a good color and good place, like kind of the microservices you need to build a data lake, a good data lake application. So moving on, similar view, but you will see like now it's more focused on AWS. So what components of AWS I can use to build all of these microservices. To begin with, I will have kind of like a router, so router of Amazon, so that I can, because I have so many microservices, I want to most probably make sure the load is routed to the right one. So because it's load balanced, because I'm using Elastic Load Balancing, depending on which part of the microservice I need to scale, I will add more nodes. So as you can see, I'm very clinical about the load. For example, an admin microservice might not be loaded that high, but a transformation microservice might be. So I'm putting my money where it really matters, as you can, and that's the power of using microservices architecture. So I'm building a gateway. I had to build a gateway for APIs to be exposed, and if there is an UI people want to leverage. So using Angular, I might store my stuff on S3 and CloudFront for static pages. I can store there. Part of the ingestion microservice, I will be using, say, S3 and Kinesis streams for capturing files and streams respectively. Again, to inventory it, I might use Elasticsearch. Amazon has Elasticsearch. You can either use Elastic Cache if you want to, or Amazon has Elastic Cloud. So there are different choices of doing it, but AWS has all of those options out there. You can inventory through Glue. So Glue is one of their latest products. So what it does is it does heavy lifting for you. So if you point it to, say, a S3 bucket, it will go through it. It will try to, based on the files out there, it will try to infer the structure. It will give you kind of, okay, this file looks like this, or this file is very similar to this. So it will give you all that metadata out there. You can be very, if you want to be a bit more creative, you can have like create classifiers or patterns. So it will use those patterns to identify your objects. So Glue kind of does like it's on steroids, doing your cataloging. If you don't want to write that application on your own, the previous one I showed like using Spark. If you don't want to do that, that's fine. Glue will do the job for you. Then I've kept the catalog service as is. As you can see, the component I just used is Redis as a background store for faster retrieval of the catalog entries. And I wanted to show that you can use whatever stack you want to use. That is the power of microservices. So in some places you're using AWS components because you think it makes sense, but for cataloging you might be still using a JHipster component to build your catalog experience for the user. So microservices give you that benefit. If this was one big application, then you most probably would have been stuck with a particular technology which was chosen at the beginning. But with microservices, that's not the case. Then obviously security microservice, we use some of the directory services of Amazon. And the next one is if you have a search microservice, you can leverage things like AWS Lambda. The reason I have Lambda in some of the places and not all, because there are some limitations on the amount of data it can request payload it can take and it can send back. So based on those best practices of using AWS Lambda, I think for search microservice, it might be a good use case. For transformation, I'm not using Lambda. I'm writing my own using Spark. You can use EMR or something like that if you want to. But I'm just showing that I have my microservice. I'm building it like that. You might not be building it the same way, but it's a choice you can have, and the choice is there because you're applying microservices on building the data lake application. Then the admin UI use Lambda, for example, and for logging, again, use for Lambda because for logging, Lambda is a pretty good component to use, as you might be doing some log analytics and all the stuff. So if you're trying to aggregate logs, you're trying to get some counts on some of the metrics. AWS Lambda is pretty good at doing it. So you can do all those log analytics and metrics using that. And so with that, let's get into like a working application, not an actual working application, but from a demo point of view. How would it look like? So first, security. So I would most probably be tying up with Active Directory through the directory service in S3. Next, I would need some data to be flowing in, so streams or files. So if it is streams, I'll get into through a Kinesis and Kinesis firehose. I'll put it into my S3 buckets. You can see like this is a best practice of using zones in a data lake. So you should be able to break down into different zones, because when the data comes in, it goes into most probably a landing zone, which is kind of in a raw format. So might be there is a very limited view of people who can see that. And once, say, you have masked sensitive data and all that stuff, you might be moving into trusted zones where more people are able to see. People can now start taking those entities and do transformation and processing on top of it. So that is the best practice of zones. If you're interested to know more, I mean, you can find a lot of material on Zaloni portal on the best practices of using zones and all that stuff. Once the data is into our zones, then you can build whatever microservices you have built. As you can see, different ones like ingesting, like metadata capture, cataloging it, running some DQ data quality, securing it. So all those microservices do the job of populating your data lake. Once data lake is populated, then the need is to process the data on top of it. So for example, you can use EMR to process data which is stored in, say, S3 buckets. You can query it through Aetna. You can provision, because when the data needs to be moved out to some other place like Redshift or some Elasticsearch, for example, you can also do that because that's driven by the kind of user experiences you're dealing with. If you have like QuickSight, you might need kind of a BI tool. So that's why you need to provision the data out from the data lake into a BI tool, for example. But if you're just using Tableau and just want to do some slice and dice of data, you can directly hook onto the data lake, and through Tableau connectors and all that stuff, you can do that. So this gives the complete picture, starting from like authentication, ingesting the data, dropping the data into the right zones, using our microservices paradigm to do different things like ingest and catalog and running transformation, and eventually all this transformed data, whatever you have done, you have processed so far, will be visualized through Tableau, Kibana, or QuickSight. With that, we come to an end of this presentation. I hope it was useful. So let's spend a few minutes going through the questions. Brett, do you might be, I don't know, might be something is wrong on my end. Do you see any questions?
I don't see any questions coming in yet. Remember, folks, if you have a question, you can use the Ask a Question box tab right below the player window. We'll probably give you guys a few more seconds here to get your questions in. All right. Well, it looks like that's we don't have any questions coming in. If you have any after the fact, or while you're watching this presentation on demand, feel free to reach out to us. Just use the info@zaloni.com email address. So with that, I want to thank everybody for joining this presentation, and to Sabby for taking the time out to speak with us about microservices for an AWS data lake. As I said, this presentation will be available on demand on Zaloni's Resources Hub and also on BrightTalk for future viewing. We appreciate your time today. Thanks again, and have a wonderful day.
Thank you.